All right. So I was talking about hooking up something. So we're going to do that. I think we're going to use this instead. This is binary. If you can see it at all on there. Can't really see it, but it's just an old rubric of a binary. It's a 100011101. But it has, 1, 2, 4, 8, 6, 18, 32, 64, 128, and 256 on the top. And how you break that down, you need a small amount of education, but you basically take a number on a legend that equals a letter or a symbol, and you feed it into this system, and you'll come out with ones and zeros. It's the bit system, 256, 128, 64-bit, 32-bit. You know what I'm saying? Alright, but what we want to do on this is get our stuff that we were going to use.
8 mil is in the house.
What's up?
Work break.
Nice. You gotta love those. Alright, let me get my clips. We're gonna time this. It's been a while since I set one of these up, but we're gonna see how long it takes me to do this. Alright, I need this over here. And it's going to go here. So we clip it to the base extension, goes up into the base, and we clip the negative to the emitter, which grounds it, basically. So we don't want these things to touch each other, so we want to just take them down real good a little bit. Don't have to be too fancy, but just keep it steady. Okay, so we'll go, this is a collector, the one in the middle is a collector. We're going to hook that to the power supply. Actually, I'm gonna want a longer one. And we're gonna hook it to the other power supply. Okay? There's too much going on that corner for me to risk a contact situation. Alright, so we take it down, we'll put it on the bench power supply. And now we're going to take the emitter, we're going to connect it to the coil. This is a Litz wire coil, 100 strands of 38 gauge, making an 18 gauge wire in thickness. Now we do need one more long order. Maybe we can make a long one. Yeah, that's what we gotta do. Gotta make it. You wanna make sure that is on there okay, because it's about to pop off. I clip the probes and then I, clip it to stuff. I don't stick the probes in because there's right. So we take the other end of the coil, and we hook it to the ground. Of the power supply. Now we gotta take our multimeter clips. And clip them to the big coil on the top. You get a reading. Now that's 12,960 turns of 32 gauge on the top there. Alright, we'll start at 200. Let's put the 3 volts in. This is the power supply we're using right here. Now let me turn on the signal generator. we go. Let's start at the bottom. Alright, we're at 10 hertz now. And I'm just going to keep going up. Forty hertz. $75 hertz. $100 hertz. So there's like, you can see the wave kind of as I go up, it'll go up and it'll go down, it'll go up, but it's progressively going up. You gotta notice that. Like every time it goes down again, like right now, it's higher than it went down the previous time. There, now it's going way down. What's going on here? 120 hertz. $140 hertz. 150. $160. $180. So I never actually done it like this, did it this way. I just went up to 427 and it was just like that. But we're gonna keep going actually past that, see if we can't get it higher. But I got 222 volts out of it. And mind you, we're putting 3 volts in. Right now we're drawing 775 milliamps. $210 hertz, and we're drawing. We're now generating 150 AC volts at 3 volts in. $215, $220, $230. Wow, we're down to 50 volts again. And now the waves are getting farther and farther apart. Or are they getting closer together? I can't tell. But we are going back up 38. The hertz in is now 386. 386 hertz. 390. 395. We're at 125 volts right now. $400 hertz in, and we're look. That's awesome. 750 milliamps at 3 volts in. We're generating 145 and 146 AC volts. That's awesome. Alright, we're overloaded now at 410 hertz. So we gotta switch this up. 204. That's awesome. That's freaking awesome. 3 volts in. $415 hertz. That's freaking cool, man. Look at how little this coil is. All right. I want to have some, I'm just going to spin it. I'm not going to hook it up. I'll explain what the, if you want me to explain this. It's an axial flux. It's got 2 SSGs, 2 batteries at 12 volts, 1 coil. So it's got 2 strands of 20 gauge in the coil. It's got 2 strands of 32 in the coil. So each circuit has its own trigger and its own drive strand. But it's all happening in this bobbin right here. It's all happening in the same coil. And you get some pretty good, you know, you get awesome resistance response. There's 2 potentiometers here. Both of them affect both circuits. So there's only like, even though there's technically 2 outputs, there's really just 1 output going out both ends. Because once it gets in here, there's a swip and a swap and everything just combines in the coil. Not 100%, and I gotta do some more testing, but I think that when they're, and especially because they're the same size now, all my other Tri-Filer Plus coils had different size wires in them. But now that they're the same size, I can do some pretty awesome tests with this thing. It's like, and no, there's no schematic. I did this last night. You know, I made this coil in my head 2 days ago, built it last night, and I think it's really cool. But anyway, we'll get back to the signal generation. We're going to go up to 420. Oh, 265 volts. That's crazy good, man. All right, we'll turn it on. I'm going to turn it on. Now both batteries are engaged. That's awesome. So we're getting 265 AC volts off of this coil, running the signal generator through the Litz wire coil. So this is using the Litz wire coil as a generator, not a pickup coil. We're going to try it the other way too. I just have to find a good generator coil to use with it. So we're going to take the little coil that's on the bottom now and we're going to put it on the top of another coil that will allow me to use the Litz wire as a pickup. This right here, this setup, is down to 700 milliamps. It is drawing a lot of milliamps. I'm not going to lie, that 700 is quite a bit. Yeah. Yeah. Alright, so it looks like 424 is going to give us our max number here. I went up to 427 last time and it went down. You can see, if I go up to 427 again, yeah, it goes down a little bit. So 272 volts at 424, and I'm sure it'll go up again because this is, like I said, it happens in waves. As you move, as you go up, you'll reach this part where you go down, but it'll go up again. So I wonder what the next up again is, what range that's going to be in. Let me, because I know once you get up really high, I gotta twist this knob a little bit. Alright. Had to tighten up the resistance, get a little bit more voltage on the meter there. Alright, are we ready to go up to the next one? So it's going down. Just remember 424. In case we gotta go back. Looks like we gotta go back.
Can you come in?
Yeah. So it looks like that was our resonant frequency, actually. Oh, and it's not going to go up. See? Here, I got to slow this down. It's going really fast. All right. See, so resonant frequency I'm gonna say is like 424, but once you go past it, you gotta reset. You gotta reset. So I'm gonna go 10 at a time though this time. Alright, here we go. Oh. 300. $390. $395. $400. $410. $415. $420. Oh, that's it. Haha. the coil wasn't centered. Ah, that's funny. My bad. So we're 272 at resonant frequency. Let's see if we can get a little more. Oh, 272. 273. Woohoo! $424. $424 hertz. Now is that the frequency for the top coil or the bottom coil or the combination of both coils? I don't know. something we can do. Where did I put it? There it is. See how fast this baby's going. 1210. So the wheel in the middle is running on 2 closed loop systems.
Let's see it.
Can't see the closed loops. All right, let me back it out. And let me zoom it back in actually a little bit. All right, you can see there. Let me move it up so I can get in the picture a little bit. There. All right, so it's got 2 closed loop systems. Got a 12-volt battery here and one on the other side. We've got SSG and SSG. 1231 RPMs. And I guarantee you there's probably twice as much torque in this as there would be in a single one. It's got ceramic bearings. It's got a maglev. It's got about 1 inch air gap, so the lens effect is really low. I've turned one of them off, so doesn't have as much torque as it did a second ago. Hold on a second. Hey, little buddy.
Not big.
So the coil here is comprised of 2 20-gauge strands, 2 38-gauge strands, 830 turns altogether. So you times that by 4, and that's the total length of wire in there. I'm not exactly sure. I use 2 full spools of 20-gauge 1-pounders. So if we know how long those are, that's how long the coil is. One second. Alright, so I think the coil is awesome. I just came up with the idea, not the idea, but like what it was going to be. I was thinking 22 earlier, but 20 gauge is really good. It's nice. Now what I found interesting is not only do these 2 circuits work together, they're symbiotic, which means when they're connected like the way they are, they won't work separately. Here, let me back it out. There we go. Perfect. So there's a lot of resistance to play with now that I got a 10-turn potentiometer right here. And I got another pot over there. So each circuit has its own pot, but both of those pots affect both circuits. If you get what I'm saying, there's only one output coil for mechanical energy, and it's all commingled. And like I said, this coil right here is generating 273 AC volts right now. But I'm guaranteeing that a lot of these volts are frothy. You know, they're not really usable. So what I propose is to get a bridge rectifier.
Bridge.
If I can find where I put it. And find out how many of those volts have transferred to DC. And maybe put a cap bank load on it. Or a battery load. Let's try a battery load. Okay. Got our battery. Alright, so we want to connect the ends of the coil on top to the battery, and we'll switch. Oh no, we want a bridge rectifier before we battery it. That's right. But as you can see, I can touch it. Because there's only 3.5 volts really going into it. Man, where did I put that thing? Little square metal. Oh yeah, I remember now. There it is. Okay, so we got a full bridge rectifier right here, okay? We're gonna hook it up. We'll get a reading off the bridge real quick. That's right. $78. Oh, but that's the AC. 274 DC volts. So it goes straight through. That's freaking cool. Now, let's do a cap bank because I'll be able to monitor that one easier. No, we can do a battery. Okay, I'm just. Whew. So now I'm connecting the multimeter to the battery. I get a reading on the battery. Nine volts. Now I need two clips. I have one. Yeah, I'm gonna have to start this again later. So hopefully there is a clip lying around somewhere. We're going to try and charge this battery using those 274 volts. Alright. I just need a clip. Beep, 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 beep. Oh. This might be useful. Turn this off real quick. Because I'm about to do something that I should have done. Oh, shoot. Yeah, that's not on there very good. Before we started it, and that's put the light bulb in to the circuit. This is a circuit right here. Collector to emitter. All right, now find that other clip. Here it is. Voila.
Nice. Got it.
Got it.
I got the clip.
It wasn't that hard. It didn't take that long.
Boss typed in, have you tried 20 gauge collector, 22 gauge base yet with your pots?
No, I just have, it's only 20,
Only 20 gauge.
yeah, I haven't tried the 22 gauge coil yet. I mean, this is what I got. This coil, it's got 4 strands in it. 20 gauge, 220 gauge and 232 gauge. And they're equal, one goes to this SSG, the other one goes to this SSG. I've tried the pots on this system, and man, it's glorious. It's glorious. I can get that wheel going about 1500 RPMs with like twice the torque of a normal motor.
He's guessing the results should be more efficient than the 2022.
No, they'll be more definitive. They won't be more what. Yeah, I understand what you're trying to say, because it'll be so different. but they don't need to be that different, and I can definitely test that out later on, but I'm really excited about my coil. I mean, I got it, it's right over here. It's actually a little smaller. It's 730 turns. There you go. Pretty equal. Except this one's got the 22 gauge in it. And no. See, I don't know. What do you mean by results? When you say I'm going to get better results, what does that mean? What do you think? What do you think is going to be better about it?
So more efficient,
Well, yeah, the amp draw is going to be a little less.
that makes more closer to unity, is that mean?
Yeah, I understand, but there's always a way to tweak this one to reach that level, and I've come very close, even with the double closed loop system.
Double close loop. Double.
And I know, it's like nails on a chalkboard, but guess what? It's working.
Works.
I don't know, I think it's the cap banks that I've put in each loop that's allowing it to work. That's what I think is happening.
Yeah, even more energy with less amps.
Yeah. Yeah, I would go 24 if I like really cared. 24 would be my number. And I got a 24 gauge coil too, right here. I've done that. And 24 really whips, man. It's freaking awesome. I got that one. This one's about 4,000 turns of 24. But the trigger broke off. The beginning of the trigger broke off. So all I got is that little tiny piece that I can clip a clip onto as long as it lasts. It's awesome, man. That coil rocks. 24, I would say, is the way to go. I like my 20 though. It moves really, really fast. So far, I mean, I've gotten 1/100 of a volt to last on each battery for, over a half an hour on closed loop system. I know that's nothing like super spectacular, but anyway, let's turn this back on and see if we can't charge this battery a little bit. Yes. Woo! Man, it's charging fast. Yeah, dude, it's going pretty fast. Not the fastest thing I've ever seen, but let's see what amp hours this thing is. 7 amp hours. It's going okay. Going okay. So I'm going to reset my pots to no resistance. Or this might be all resistance. I don't know which way I have it set up, but I know by feel that when I turn it this way, it's a good start. And then we can start turning it the other way and it'll go faster. All right. So, we can see it start to kick. Alright, let's give it some juice. I'm gonna try and charge this one up to 12. It's probably not gonna happen on the stream, but
Boss said I found that gauges that are closer to each other in size gives you more energy pulse.
they're exactly the same. Do they have to be different, or can they be exactly the same?
I think he's given an argument for it's different. That are close. Like 2022. Different by 2 or 3 gauges.
Okay. These clips are contacting on the pot. Yeah, I don't have the proper connectors to make this pot work efficiently, really. I mean, it works, and when it works, and then when it contacts, it's not working. So. But it's working now. So the amps have gone up to 800 milliamps on this system. It doesn't look like it's generating as fast anymore, does it? Is that because we're getting pushed back on from the capacitance of the battery? I don't know. Maybe it's because everything is different now. I mean, look. I gotta hook up the clips to a different part of the system to see anything different. It is still going up, man. I'll just leave it alone. But we would hook it to this coil. Wow. Hold might get some minuses here. Yeah, we'll definitely test out the 2022. And I understand exactly, you know, what you're saying about that. Alright, I gotta deal with something real quick. Nine volts. Wow, oh man, sometimes it's really hard when your kids are, you know, socking each other in the face.
That's what it sounds like. Yeah.
Our amps are going through the roof here. So we lost some traction here. Something's not right with it. Alright, I'm gonna shut it down. I think that's some, when I messed with it, it must have tripped because we're drawing like so many more amps. But the cool thing I've been doing with the signal generator is putting it on the trigger coil of this circuit right here. It gives an interesting torque boost to the wheel. Alright, so turn this on. Turn the power back on. We'll start from ground zero. So we're drawing an amp now, we gotta turn that up. And that's with just 3 volts in, you know, so it's, no, something's not right. It could totally be, that's gotta be what it is. Ooh, yeah, that's it. Haha. Come on, man, I hate my clips that don't do what they're supposed to do. Haha. The light that I just put on there was contacting, the clips were contacting. There we go. See, we're back. Bam. Ugh. You got your light bulbs dangling there, and then if they touch each other, whoops. Sorry, I make that noise when it's like a dumb mistake. But I don't know, maybe there are no dumb mistakes. You gotta just be really aware of what's going on around you. I'm just glad I know what to like look for. So I'm gonna put 5 volts in now. See, when I turned it up to 5 volts, when they were contacting, it got really hot. It got really hot. It was like drawing 3 amps. So this is 5 volts. See if the rate goes up significantly. But then, you know, with the increase in voltage, you got to do the whole signal generator thing again. But I think we're at a good spot where it's going to continue to increase at a pretty significant rate. Because in order to do the signal generator thing again, I got to unclip the multimeter and clip it back up to this coil so we can find the resonance. Oh man. Okay, I stepped on the clip here. the appropriate connectors, I do not have to run these 10-turn pots. So, yeah, it's a struggle right now. Yeah, that pot smells hot too. Alright, I'm gonna turn that off. I'm gonna try and get some better clips real quick because these ones are just touching each other. So when I turn the voltage back down to 3, it dropped. So alright, that looks like it might work. Don't need to get any different ones. Alright, resetting the pots. So we're gonna start. What shall we do? Let's flip. Let's get this one out here. Use some Litz wire coil as the pickup coil. So, but that's weird. Something's not right with that. Yeah. Huh. That's what it was. Alright. I had the DC power reader on. This is AC power, so that's why it was reading funny. Yeah, I'm not getting anything off of it. And that, just to be sure, I'm gonna put the big coil on top again of this bigger coil. We're just gonna swap these out. Let's see if our system is working or if something happened to it. And then, yeah, the meter's hooked up to the bridge rectifier, so it is DC reading. But like that was 10 DC volts with no power, so something was not right. Like right now, it doesn't. So it's 10 volts. So does that mean that this coil is producing 10 volts? Let's turn it up a little bit. Yeah, nothing. So I'm thinking that when my lines crossed, my transistor grew. That had to be what happened. Because this is not working right now. But it's cool because to swap a transistor with this system is easy. So I'm going to do this. If we get a different response, yay for me. Make sure I got the right one. Yeah. So as soon as I figure out PNPs, I got about 400 PNPs that I can use. All right. I must have something hooked up backwards. It's not fucking working. Jesus. So, and that's not working either now. It is working, but it's not. I gotta focus. This is light, man. God, I thought I needed it. Let's take it off, see what happens. Looks good now, because there's zero. Let's try it. Yeah, it's working now. Yay, it was the light. The light was probably dead or burnt out.
Alright, problem solved.
Problem solved. Get rid of the light. So let's get the Litz wire coil back up there. We'll cut the power. It's nice. Thank goodness that it wasn't something totally crazy. Got my background vocals kicking, kicking.
Awesome.
Tossing and turning, flipping and flopping. So now we're going to use the Litz wire coil as a pickup coil. Here we go. Oh, we got 1/10 of a volt at 60 hertz. So I'm thinking it's a really bad pickup coil. But let's see if we can work it at high frequency. Let's start at a kilohertz. It says for high frequency applications, that's a kilohertz. That's 2 kilohertz. 3, 4, 5, 6, 8. This is picking up at like 10 kilohertz, man. That's pretty good, actually. It's not picking up that much, but looks like a kilohertz pretty close. A little lower, a little less than a kilohertz. Oh no, there we go. 400 hertz. It's like 400 hertz range is the range. That's the range. Sweet. But it's not even generating a volt. Not even a volt.
1 volt. A whole volt.
A whole volt?
Not even.
1 whole volt? Not even close. So yeah, I'm gonna hook up. I'm gonna take the Litz wire out all together right now, and I'm gonna put this one on the top by the panel, and I'll be right back.
Blam.
I'll figure that out in a second. I'm working on this right now. Alright. Let's... spin it the other way. Because I can spin it faster the other way. Because I don't think it was quite catching with the amount of air gap that it had. So no, Litz wire is definitely the best generator by a long shot. This demonstrates that. So it's like, hold on. Yeah, I was going the wrong way with that. Hold on. This is going up. We're almost at 200. There, we're at 212.
View.
Nice. Awesome. Alright. Yeah, I don't know, man. I'm gonna hook back up the Litz wire coil as a generator. So, I know people are going to come at me and be like, you know that the other one's a better generator, right? And I'm like, well, this experiment kind of is saying a different thing. It's saying that the Litz wire coil generates a lot of power that this picks up. is this one? Hold on, I need to make sure I got everything. Oh yeah, this is for the battery. To attach to the battery. Okay, yeah, that's good. We're not gonna do that just yet. So we'll go 3, we'll go up to 5 volts in. Five, 3, 6. Alright, let me go to the signal generator. And this will charge a battery at a pretty rapid rate. That is 1 hertz. Oh no, that's 100 hertz. My bad. Okay, it starts kicking in at 8 hertz. You know what? Let's start this one at a kilohertz. Let's do that. $13.5, so it's not. Yeah, it's not that high. There's 100, there's 200, 300, 400, 5, 6, 7, 8, 9, 10. Okay, so 400, and then we'll go to the next one. Raise it 1. Oh, whoa! 410 is going to take it to 621. 334. Holy smoke! We are at 5 volts in. 430 hertz is the resonant frequency. 342 volts at 5 volts in. We are drawing about an amp though. So 3 watts. Unfortunately, this meter does not read amps, but probably hook up one that does. It was caught on a clip. Haha, the pot was caught on a clip. So now I have a coil with different strands and a coil with the same strands. I've been told both ways are better by different people. 352 volts. That's freaking amazing. Wow, it's going up too. I think this is one of those points where it'll continue to rise. We'll see. We'll check it out. I don't know if we're gonna get that wave again right now. I'm kind of distracted. This battery's a little low. It's literally at like 11.93 now. I'm gonna just ease this up. We're gonna try and catch it. Just like rolling a sphere in a jar. You know, you gotta raise the hertz one at a time, and then it'll continue to rise. We're getting there. And this is a good place to chill and let it go because it just went up a hundredth of a volt.
I gotta go to the bathroom.
Okay.
I'll be back.
All right. So I guess what we can do is now equip the battery charger . I mean, and once you resonate, it's scary. Like this thing is going really fast. It's not the, it doesn't have a casing or anything like that, so it gets kind of personal, you know? But like I said, this one battery over here is getting kind of low. Had a lot of contact over here, so it had massive voltage drops. I'm talking like tenths of a volt at a time. So we're using this solid state right here to charge this battery. This is its progress. That's a nice pace, very slow, very safe. We'll give it another quick jump start and see if we can't make something of it.
Probably about 10 more minutes.
See that bearing pop up? Alright. Coolio. So how far are we now on this? 10.42. That's awesome.
Nice.
See how this is all tame right here? This is all that tame. That's how they call it farmers too. Lots of stuff.
Alright, so I guess the next thing we're going to test is the coil that I have over there. We'll find some way to fire the second switch, or the second coil. I'll think of something. That'll be for next time. There'll probably be an external trigger, and we'll be able to experiment with that as well. But with the 20, 22, and 30 gauge, we only have one trigger strand in there. So, yeah, we'll have to figure something out. And I already experimented with trying to use one trigger for both, and it won't work. So, gotta have another trigger strand or another trigger of some kind.
You do like 20 flips in a row.
Yeah, I can't think when he does that, but it's awesome to watch. All right, let's see. At 5 volts, we are now generating very slowly. See, it gets up to that one point where I think they actually like level off. Should be right around where it is now. But we're gonna wait and see if it goes up again. Real quick, how many minutes? Like 5, 4, 5 minutes. We'll see what happens in the next 5 minutes. 193. '96, 193, 194, 195. That's a step in the right direction. Yeah, I'm gonna have to charge the battery for sure.
Charge the battery. Oh,
Show, man, because 11.91 is where it's at right now. So I'll charge them both up. Yeah. It's great though, man. That thing will get going so fast. Alright, so it's still going up, still charging. There's probably a new resonance that will allow it to charge even faster. But I don't know about that. I don't know. I'm just guessing that as soon as it gets to its max, you got to do it again to achieve another max. Awesome. Yeah, see, it's starting to move now. The rotor. It does move pretty fast. Alright, I'm just shutting everything down. Thank you very much for tuning in, ladies and gentlemen. We'll be at it a lot, so keep tuning in. If you have any questions, don't hesitate to ask. What is this? Let me just explain it real quick before we sign off. This is an axial flux pulse motor, which is running on two SSG circuits, which are both run through one singular coil. We're going to try a lot of things, but this is how it's set up right now. With both circuits going into the same coil. 20 gauge and 32 gauge for the trigger. And as you can see, man, this thing will get going. It'll start moving and it'll start shaking. It'll move so fast. And it's very well balanced. Anything that you see that is not balanced is tape. It's a little corner of the tape that's sticking up. That's the only thing that you see here. It's an optical illusion. Yeah, and there it is. There it goes, ladies and gentlemen. Thank you very much. I'm glad it decided to take off before it was excellent. But I'm going to stop it now. Closed loop system. Each circuit has its own battery that it charges by itself. Of course, both systems lose energy, but it lasts for quite a while. The closed loop systems are pretty much charging themselves, give or take, some time. Will it last forever? No. And if your goal is to make it last forever, I don't know what to say. That would never be my goal. I'm not going to last forever. This world is not going to last forever. Nothing lasts forever. And if we keep on getting farther and farther away from everything else, we're going to get really, really cold. This place is going to freeze. And all the water in it with it. It'll be a big old ball of ice. Do I know that? Yeah, I know that. That will happen. Just going to take some time, that's all. And if you do the math, eventually this is going to be a big ball of ice because it's going to be too far away from the sun, if the sun is still around at that point. And you got to think, I think this entire universe is in a black hole. You get what I'm saying? The entire structure of the universe is in a black hole. Because space, it gives the impression of being black, but what it really is everything mixed together. The ether is the essence of the black hole. Because black is all the colors mixed together, if you get what I'm saying. Right on, man. I get way off track talking about stuff like this, but I love it. I love it to death. Thank you very much. Peace out. Have a wonderful day. Bye now.